All right, hello everyone. Welcome to the WolfCell live webinar, how to get started with libcURL with Daniel Stenberg. My name is Marcos. I'm going to be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box at the bottom of your screen. We'll be answering questions in a Q&A session following the presentation. Our webinars are recorded and made available on our YouTube channel. I invite you to follow us on Twitter at wolfcell as well as our other socials. Also, feel free to email us at facts@wolfcell.com if you have any additional questions. I'm going to give a quick company overview before we move on to the presentation. wolfSSL was founded in 2004 by Todd Oska and Larry Stefanich when they realized there wasn't an open source, well-licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 50 dedicated employees in 2022, most of which are engineers. This progress is of course supported by a strong partner network that we're proud of, which includes DDCI, STMicro, and RTI, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with DO-178 support, FIPS certification, and FIPS ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as Wolfboot, as well as Java wrappers and JSSE support, and commercial support for curl. All these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And I'm going to hand it off to Daniel for the presentation.
Thank you. So getting started with libcURL. So yeah, I am of course Daniel Stenberg. I founded the curl project a long time ago. We actually turned 24 years very soon. Yes, so I work for wolfSSL and we sell curl support. So if you have any problems with curl commercially, get in touch and we'll help you out. That's my website and I'm available on Twitter as well. So today I wanted to this is called getting started. So I'm going to try to go through some basic about libcURL and how to do transfers using libcURL. A little bit about, I'm going to focus on how to do synchronous transfers because that's the easy way to do it. I'm going to get into how to extract information from a transfer, also of course how to properly receive data and upload data, and then a little sort of a teaser on how to do multiple or concurrent transfers, many transfers simultaneously, but I'm not going to spend a lot of time on that. And then of course there's a Q&A afterwards, so if you have any questions, save them up or press that little Q&A button up there in the Zoom controls and enter your question, and we'll get to them in the end. I know a little bit about libcURL and curl in general. So the basics. libcURL is I want to just clarify on the naming. I usually call everything curl, and a lot of people refer to everything curl, but really curl, usually sometimes we use this with uppercase URL as in the project name, and then the lowercase curl for the command line tool, and libcURL as the library. But we're sort of, it's a little bit of a mix and match, so we use it interchangeably many times. So often we call the curl the command line tool curl, but there is also the curl library that is often libcURL. So yeah, it's a little bit of a confusion every time we talk about curl. But in this presentation, I'm going to focus on curl as in libcURL, the library, how to do transfers using the library libcURL. libcURL is, of course, completely open source and available. It's MIT licensed. It's not exactly MIT, but it's in principle MIT. And as I already mentioned, we have a commercial support available. I'm not going to get into explaining this a lot, but of course you need to get libcurl first, right? In order to use it. So most users, if you're on a Linux machine, for example, you install it because your Linux distribution provides it as a package. You just get it, install it. That's the same thing. If you're on Mac OS, you usually get it from Homebrew or something else. It is actually provided by default in Mac OS. So if you're happy with the one that Mac OS ships, you can actually just go with it as already there, present in your machine from the moment you install it. And it's sort of the same thing on Windows. Is possibly even more complicated, but still, read up on that if you don't know the details there, because I'm not going to spend a lot of time on that today. You can, of course, also build it yourself from source. That is also sort of easy and often done by people. And then you, of course, write your code, and you build your code, and you tell it, you link it with libcurl, and you sort of instruct the compiler to use libcurl for the transfers. So you need to know where the include files are and how the linker can find the library. So you need the include files and the library. And if you're using GCC in a typical, well, maybe you don't GCC always on Mac OS. They tend to go with Clang, but it's the same kind of, you use the compiler, you tell it to link with curl, with the lcurl option. And usually if you have installed the headers on a default location, you don't need to tell the compiler where to find the include files. And then you just compile your C code like this. But it's also important to remember that there are a lot of different libcurls, and we try to clarify properly everywhere in documentation which options are available when and what they sort of depend on and required to be there to work. But you should be aware that we ship libcurl releases very often. So if you go from one box to another box, you might find different libcurl versions. If you go from your Linux machine to your Mac OS machines, they might ship different versions from their package providers. And of course, we have the different platforms, so they will be slightly different, and there will be different features enabled in different builds. Maybe the person who built your package on your Linux distro enabled one feature, and maybe that feature wasn't enabled in another platform. And also, even if you enable features, they might sometimes depend on different backends in the back end of libcurl. So maybe they depend on different TLS libraries, for example. And they can also then ship in different versions. Like if you're using OpenSSL, OpenSSL comes in different versions too. So on one platform, there will be one version and another one. So a lot of different flavors and combinations, bazillions of them really. Just to keep in mind, because that may sometimes, when you run into problems, that might actually affect you and be reasons why you see the different behaviors or problems or whatever. And we take documentation seriously. We make a serious and really, really strong, hard effort to make sure that we document everything rigorously, thoroughly, and a lot of it. So every function I'm going to talk to you about today, and even those I'm not going to talk to you about today, have man pages. Each function has its own man page with details, with examples, with also with descriptions, clear, and a lot of words describing what they do and what they don't do. And every option for all these functions also has their own individual man pages. So there are a lot of different man pages and a lot of documentation. And if there's any doubt at any point, check out the man pages, the documentation. We also provide more than 100 standalone tiny examples in the packages and on the website, sort of if you want to have a more, see how they work together. And all of that is available on the website, and that is also commonly updated. So even when we fix typos and stuff along the way, the web page automatically updates and always serves the latest documentation. If you want to have a more of a explainer tutorial thing, like we have this book, Everything Curl, which sometimes is easier and a better resource than man pages. The man pages are better if you look up, if you have a specific, you want to know about this particular option. But if you don't even know which option to go for, search for, maybe the book, Everything Curl, is the better entry point for you. And really, if you have an option or function name, just Google it. The chances are our public official documentation pages are the primary search results for them. So it's easy to find, easy to get to. In libcurl, we have a tradition and a really strong effort to never break the ABI or API. So whatever you use today, when you write your application today, you should be sure and you can rely on libcurl to not break this. So when you go forward and update your libcurl tomorrow, next week, next year, in 5 years, you can be certain that your application you wrote today will continue working pretty much unconditionally forever. We keep features, behaviors as we have introduced them. And that sort of means that as we don't break the API, we maintain the SO name. We haven't bumped it now in 16 years. And also, which is an important factor here, and that is really practical, useful to know, is that we don't, I mean, the API works exactly on all the same, it works the same way on all platforms, which is a convenient way for you to bring on your applications to other platforms. If you write something using libcurl, you can move it over. You can write it on one platform and run the same libcurl using code on other platforms like, Linux, Mac, Windows, real-time operating systems, whatever. The API is there and it works the same. Of course, with that little caveat that some protocol features might be disabled, enabled in different platforms. And then, of course, you might need to adapt to that sort of runtime problems, perhaps. So, and that's sort of the ground principles of libcurl. And in libcurl, we have a few different sets or maybe families of APIs. We group them by prefix, and we have the easy. Those are the ones we are going to look at today. Maybe not the most clever name. Blame me for that. I wanted to have an easy interface when I created libcurl the first time, and then I thought it was a good idea to call them easy. Maybe it wasn't that good, but that's how it is now. So curl easy functions, they are set up to do mostly the synchronous way of doing file transfers, one file transfer at a time. And then there's the multi-family, the multi-interface. That's the more complicated or more advanced way to do one or many transfers concurrently in a non-blocking way. And then we have the share interface, which is a way to share data between multiple transfers. And we have the URL family, which is a set of URL parser functions that helps you manage URLs as strings. And there is a little bit more, but that's how we have split it up, divided it. So there are sort of different families of API within the big libcurl API. And in total, I think we're at some 80 something functions. So it's a manageable amount. And among the curl easy ones, I think we're at maybe 20, 25. But okay, going forward, when we want to write, we use libcurl for internet transfers, right? And there are some basic principles when it comes to the API when we do transfers using libcurl. It's very oriented around transfers. The entire API, the library, really, we work on transfers. That's what we do. We transfer data up, or we get transferred, or we get data down, or possibly both, right? Upload, download. So you create, set up, and perform transfers. And a transfer in libcurl, it's always oriented, or sort of you transfer to a URL or from a URL. There's always a URL as an endpoint. That's the other end, right? libcurl is always a client library, so the client talks sort of against a URL here, or that's the target or source of the transfer. Yeah, send or get data from that URL. And here's another basic principle, is that the default transfer that libcurl performs or makes is as simple as possible. So it's basically does only what it needs to. Everything else you need to enable or add or customize yourself. And that is something to remember. So, and also that the API is protocol agnostic, so it works on URLs, But if you don't want to, you don't have to care about the particular protocol that is used underneath, right? You don't actually have to know a lot about FTP or HTTP or whatever protocol you're using. You're using that in the URL, but you don't need to know a lot of protocol details, and libcurl will mostly provide that API independently of what kind of protocol is used. And just change behavior by setting options. And I will show you how to do it. You create a handle to do the transfer, and then you set options, which is a little bit from a few options to many options, depending on your use case and situation, of course. And a transfer in libcurl is always oriented, is always done really using a curl handle. Often we refer to them as easy handles because they originate from this easy API. So an easy handle, you write like this: curl in uppercase, asterisk, and the name. That's how you declare one of these variables in C. And when you have one of those, once it's created, and you create it with a function call, I'll show you in a second. That is the handle to a single individual transfer. So that's good. That's a handle to a transfer. And if you want to do another transfer using the same handle, that's fine. You can just do another transfer. You don't have to close and create a new one. You can just reuse the same one. And that we encourage reuse of handles, because the handle then has some caches and other things that makes it actually makes it faster to reuse a handle rather than create a new one. And when you set an option in a handle, the options remain set until you change them again. So if you set a URL in a handle, it'll have that URL set until you change it to another. So if you can, for example, create a handle, do a transfer, and set a URL for that, do a transfer on that handle, and if you do a second transfer using the same handle without changing anything, it will do the same transfer again because the same options remain set. And options, when you set an option, if that option accepts strings like C strings, they will copy the data, which is just useful to know who's handling the memory. You don't have to keep the strings around after you set this option to libcurl. There's only one mandatory option, so this is the only one you really need to set, and that's the URL, because as I told you, the API needs a URL. You either get a URL or you send to a URL. So there's always a URL involved. If you haven't set a URL, there's details lacking, because then libcurl won't know what to talk to or what's in the other end. So the easy interface is like this. It's made for synchronous transfers. I think I said it several times already. So basically, when you do a transfer, you do the entire transfer and then the function returns. So if you want to do something else in the meantime, you need threads, or you just have to wait for it. And of course, when it returns, it could either return successfully or it might have failed and then it returns an error. And it will always do this as fast as possible by default. So basically, the faster network you have, the closer the server is, the smaller the resource it's going to transfer is, the faster it's going to return, which then might be almost instantly if you're on a really small file over a fast network, or it can take a really long time if you're doing a huge transfer over a slow network. So there's really no limit in how long a transfer can take. It can certainly take weeks or months or years, even if you just allow it to take that time. I suppose very few actually take that long, but anyway, you can. And then you can, maybe you don't want the transfer to go on forever, or possibly go on forever or weeks. So you can then set maximum limits. For example, you can set never allow this transfer to go on for longer than this many seconds, really, or however you want to limit it. There are several different ways how you can put on restraints on the transfer, so to tell it to stop it if it doesn't meet certain conditions or if it meets certain conditions. So you create an easy handle with this function, curl easy init. That's the way, and it returns a new handle for you. So this gets you this easy handle, and then you have that handle, and curl has then initialized this really with some default values, so it's ready to be used, and it has a lot of defaults set up, so you can just go ahead and use that immediately. Well, you haven't set the URL yet, so it doesn't know what to transfer, but if you set the URL, you can use it at once. And it's important here that the handle here is just an opaque handle. It's just a pointer in C. There's nothing for you to read from this, or there are no struct fields or members in this. This is just a handle, similar in spirit to how the file handle works in C. There's basically, that's a handle. The easy handle is a struct pointer to a transfer. And of course, when you're done with the transfer, the reverse to curl easy init is the curl easy cleanup. Basically, that's a malloc and a free, or something like that, open and a close. So you kill the handle again with curl easy cleanup, and it will free all the resources, and everything is back to where we were before we did easy init. So we do the easy init to get a handle back, and then we set options, and then we use curl easy setup. And in this case, a little example here on the screen, we set the URL to https://curl.sc, and that's just a C string, and it will copy that string. And if we then we perform the transfer, we will just get that URL down to our client. You can set different kinds of options, and they have actually accept different argument types. So you need to check your option, what type does it want? Like the URL wants a string, so the curl opt URL, you pass in a string. There are also many options take a long, and there are some other variations of things. You can also set a lot of callbacks. I'll get to that in a second. Let's show you the basics first. And of course, documentation I mentioned. So there are a bunch of different options you want to set. The most common ones, like you need the URL one. Setting verbose is very useful. You could set the buffer size to tell curl to use different size of buffers, maybe make the transfers faster. It'll also use more memory, of course. Error buffer to get better error messages back. You can set the write function, which is a callback to tell curl to use instead of writing data to standard out, which you rarely want. You can also give it a read function to point out how to read data to upload. And you can tell curl, this is the timeout. Never take more milliseconds than this, and return if it takes any longer. Or you can just limit the time you allow curl to use for the connection phase of the setup of the transfer. Yeah, and there are a huge amount of options available, so you can customize the transfers quite a lot. So how to do the transfer then? This is this only single call then. This takes the transfer handle, the easy handle here that you already created. You set the options for it, and this function performs. Yeah, it's called curl easy perform because it performs the transfer on the easy handle, and it returns the result. If everything is fine, it'll return okay. And then you know that the transfer has been performed as you instructed. If it didn't perform as you instructed, it'll return an error. And there are, I think, almost 100 different error codes. And there's also a function to convert that error code to a string if you want to. So if you want to go then, okay, a total of how does it look in source code? I'll show you in a little second. There. All right. First of all, there's only one include file to do. So if you run, there's only ever this you need to include in your source code. There are, within that curl subdirectory that you see here, there are a few others, but this main header will include the others. As long as you include this header file, you'll be fine. So the minimal easy example works like this. Let's see if I can hide my things on my screen here. It's in the way for me. Anyway, so here's again, you create the easy handle, and if it works, it might actually fail if it runs out of memory or anything. You set an option. Again, we need to set the URL. So maybe we want to download the example.com HTTPS really resource. And in this case, maybe that's a redirect. Please, libcurl, follow redirects if there's one. So this is just, it tells curl to follow this redirects if there's any. Oh, and then do the perform, please, passing in the easy handle as an argument, and now it will perform the entire transfer. And since we haven't told curl where to put the output, we haven't provided a write callback, it will just send everything to standard out by default. So if you run this program in a terminal, you will get the HTTP or HTML really from example.com sent out in the terminal. Maybe not what everyone wants, but and okay, here we check the return code. Did it return okay? If it didn't return okay, if something failed, we output the error code. And here is the function. The curl easy error converts the error code to a string and outputs it. Easy. And then, of course, as I mentioned, we clean up the handle after the transfers to free up all the memory that curl has used for this, and then we're good. We're done. It's that easy. So basically, remember, here are the steps. Again, we create the handle, we set up, we do actually a typical code would do a lot of setup calls, maybe 5, 10, 15 of them to set different options. And then we perform the transfer, we clean up the handle. Of course, we can go from perform back up to setup and down to perform again. If you want to do, we can loop between point 2 and 3 here. If you want to do many different transfers, maybe. But okay, we want to send and get data, of course. I guess maybe the most typical use case is to get data, like download something, maybe over HTTP or HTTPS. And then we provide a write callback. Here, the verb is from the point of libcurl. Libcurl wants to write data, save it locally. So we provide a write function when we want libcurl to write that somewhere. And when we provide a write callback, libcurl will call that function instead of writing it somewhere else. So the function, the callback prototype is then like this. So the first argument contents is a pointer to data. This is actually the prototype of fwrite, the C function. That's why it looks, that's why it have 2 arguments for the size, because the size actually comes in size and n member, as in number of members of the size. So actually the total size is actually multiplier with those. A little bit inconvenient, but this design choice I made about 22 years ago. I regret that a little bit, but yeah, we can live with it. And then the user p pointer, the 4th argument, is what you set with the another option, actually, curl opt write data. So that's just a opaque pointer that you set in your application, and it will just be passed to the callback. So it's your pointer. You can point it to whatever you want and deal with it yourself. It's a good way to pass in local data from your function into the callback. So yeah, here, yes, the real size then, to get the actual size, which is the number of bytes that the write callback has been given by libcurl, write this many bytes somewhere. And the data is there in the contents, as I mentioned, and that's the user P that we have. And typically then we would save this to a file, store it in memory, pass it on to another computer, send it over a pipe. We could perhaps just parse the data and be done with it. No, we didn't find any bad stuff in the data, just return real size and say we're done with it. And that's it. That's what you do in the write callback. And of course, this is just, you write whatever you want. You handle this however you want. It's your data, you decide. And then you just return to libcurl, the number of bytes you dealt with, which really needs to be this amount, because otherwise libcurl will think something went wrong and will return an error for the transfer. And reversely, if you want to send data instead, you do pretty much the same thing, but the other way around, if you want to do it as a callback. But in libcurl, we have 2 other ways of sending data, because why do it? No, but because you have different requests or wishes. So you can do the same thing and provide the data in a read callback. I'll show you in a second. Or you can provide the data. For example, this is just a string post fields. It's designed mostly to do HTTP post. If you just have your data in a string, I have 22 bytes, I want to send this as a string. Just tell curl up post fields and libcurl will send that string to the other end as a HTTP post. Or a more complicated way is to do multi-part form posts, which also is an HTTP way to send more structured data over HTTP. Then you use this option. I'm going to focus about no, I had a post fields option example here, and that, as I told you, that's just send a string, whatever. It's a C string. So in this case, we want to send 5 bytes, and they are HELLO, called hello. And so you just tell the URL where you want to send this as a post, and then curl up post fields will tell libcurl what data to send, and then bam, it'll send this as an HTTP post to that URL. And the same as before, check the return code, output error message, clean up the handle, and we're done. Right, and you could do that the same thing with a read callback as well. If you want to, for example, provide data from another process or from a pipe or from memory buffer or however you want to do it, then you can do it with the read callback instead. Easy peasy. And when you've done a transfer, maybe you downloaded something or uploaded something, you want to get some information, some metadata perhaps about the transfer after the information has completed. Then we have this function called curl easy get info. So we're still in the easy API. So get info. We want to get info after transfer has completed. And then we can extract stuff like curl info effective curl. For example, I showed you before how we told curl that it was okay to follow redirects. So maybe it followed a redirect to a second URL or a third URL. You know, redirects can go on and on. It could be a chain of redirects. So this is a way to figure out, now tell me which was the effective URL, which URL did you actually end up on eventually. So ask libcurl, it'll tell you. Or you can get the response code from the HTTP response you got back. That's, you know, a 200 if everything was fine and dandy. Maybe you got a 301 because it's a redirect and you didn't ask for a redirect to be followed. Maybe you want to ask how long time did it take? How fast did you download it? Or maybe just the content type or anything. There are many different of these variables from curl easy get info that you can extract after a transfer has completed to sort of, yeah, get info from it. And this is how you do it then just in source code. So you do that easy perform as, again, it performs an entire transfer. And once the transfer is done, it worked. It returned okay. Then we extract data. For example, in this case here, we ask about the content type. That's a header in the response. And it'll return, if this works, it'll return okay. And we will get a pointer to that particular header. And in this case, it actually checks that it was okay. We got a pointer and we output the content type in the printf here. It's that easy. And there are, as I said, we can extract a lot of other info from there as well. And of course, when you do it, we start to get the feeling for this. We start to transfer data. Sometimes, actually, quite often, things don't actually work exactly the way you want it to. And you start to wonder, well, I'm using libcurl right here, but why doesn't it do what I want it to do? And then, of course, you start to debug your libcurl using application. And then I have a few tips and tricks that I think you should remember then. Of course, always read the docs for the libcurl function that you're using and read it again. I think sometimes you get fooled because it uses plain names and English names. And sometimes you think just because it says so in the name, it will do this that you assume it does. But read up on it. Maybe it doesn't actually do it. It'll help you. And then, of course, which I have been a little bit of a cheater here when I showed you examples, do check return codes, because if libcurl returns an error, that's a good explanation why it didn't work, right? And the error code is there and it says something, it explains something to you. set the verbose mode to enable verbose mode. It's really handy. It'll output extra data, extra verbose data on standard error usually. Or you can actually set up a callback to receive it differently as well, because it'll help you. libcurl will tell you stuff from its internal engine that it will help you and explain some of its doings and some of why it doesn't do things. And another thing to help you is I've shown you how curl returns an error code, and you can convert that to a string. But if you provide an error buffer and give that to curl ahead of time, it can actually provide even better error messages that are more well scoped and for that particular error that happened exactly when you ran into that snag. And then the next level is a debug function. And the debug function is sort of a verbose and error buffer combined on steroids, because it'll give you everything that curl sends and receives, and also internal messages. So it'll give you the lot, and you can work out the problems pretty well. And of course, if you're on a machine that can run Valgrind, that's your friend, and you should use it. And really, if you should, that's when you have a memory problem and using libcurl, that should be your first weapon of choice, to just run your application using Valgrind. And if it reports an error, that's where you should start focusing your problem, your research, and fix that first. Because libcurl doesn't cause any Valgrind reports or errors by itself. So if it does, you probably told libcurl something crazy. And of course, if that doesn't help, if you completely run against, banging your head against the wall and it doesn't work, remember that there's a curl library mailing list. We have over 1,000 subscribers, a lot of eager, good developers there reading the list and can help out with problems. I read it, I respond to it fairly frequently and quick, actually. And of course, if there's any bugs, you report them on GitHub, and always consider getting a commercial support, because then we can help you even faster and privately, and more hand-holding or whatever you need. So, and when your application, well, maybe not only when you want to go to the next level, but maybe that way of doing synchronous transfers isn't really the way you want to do it and can do it in your application. You want to do maybe non-blocking or transfers to do other things at the same time as you do the transfer without using threads. You can always use more threads, right? But this is a way to do it without threads. Or you can also move the event handling to your own application away from libcurl. So basically, then we go into the libcurl multi-interface. Multi, of course, stands for multiple, so multiple transfers, but it doesn't have to be multiple. You can use one as well. And the interface allows you to do them concurrently, non-blocking any amount of transfers, really. And again, in a single thread. It doesn't use threading for this. It just is a complicated state machine. And of course, in this case, you can actually do a lot of transfers in parallel, and you can add and remove them sort of in the middle, right? You don't have to start 20 at the same time and do them all until the end, but you can actually start with one and then add more along the way, or remove them along the way, or whatever. It's your choice. You do what you want. And the multi-interface moves the event loop handling or to your application. So libcurl itself won't wait for activity on the sockets or whatever you want to wait for. You do that waiting, which allows you to wait for other things as well. You can wait for libcurl sockets and your own sockets and your own other events or whatever. The freedom is totally yours to do exactly how you want it to, how you need it. And with the multi API, it's sort of a extended easy way, because you still use easy handles, because just as before, the easy handles are handles to transfers, individual transfers, and that's always the case with libcurl. Then you create a multi-handle. That's a home for many easy handles. So you add all those easy handles, and all those easy handles are individual transfers, right? So if you create 400 easy handles. You can add all of them to the multi-handle. So then you can have 400 transfers. And then you tell libcurl, drive these transfers, sort of do them, and it will do them all in parallel, concurrently. And it will return as soon as it would have blocked. And I'll show you how it works in source code. So you create easy handles first. Maybe you do 2 transfers just for the sake of it here. And then you create, let me see if I can move this. Yeah, so you start out with, in this case, 2 easy handles. You set options. Maybe you work on 2, in this case, I'm just, I need to have some examples here. So I made an HTTPS example.com and then an HTTP from localhost. Maybe you don't actually transfer like this from localhost. It could be another one, or, it could be whatever. And then you create the multi-handle as a home for all those easy handles, and you add the easy handles to the multi-handle like this. Just put them in the multi-handle, and then then we start a little loop here. So as long as we're not done, which of course we're not done yet because the transfer hasn't even started, but as long as we're running, we perform. And when we call curl multi-perform, it will drive all the transfers until it would have blocked, because it won't block. This is a non-blocking function, right? So it'll return when it has maybe kicked off a little bit. It has done a little bit of the operation, and then it returns. And then it might, of course, have completed everything in one call. It could have done it more in sort of, if it's super quick and super fast, it might have already be completed by now, but maybe it wasn't completed. And then we can ask curl to, well, we want to just hang around here until there's an activity on one of the sockets, or 1,000 milliseconds have elapsed, and then we continue. Or if something failed, we can also break the loop, and otherwise we're looping. Basically, we are right. But we can also, since then when we're doing many transfers at the same time, we want to know, but what about when one of the transfers have completed, right? So how do we know if we set up 200 transfers? We want to know when each of the transfers are done, or each is done. So in this case, we call the curl multi-info read, which then returns a message if there's something that has happened. And the happened here could be a completed transfer. The curl message done here. Yes, this transfer completed. And then we're good. And we can just ignore that it actually completed, because as long as we do this loop still running, it'll actually just, the brace up there just before this final line will actually then loop. So it'll, in this while loop, will go on as long as there's something to perform. As long as the transfers are alive, it'll loop through this, wait for activity, check if there's a transfer done, then loop, and on and on and on until it's done. And here at the end of the loop, then we remove the easy handles again from the multi-handle, because they're now done. They're completed with we don't need them anymore. And then we clean up the multi-handle, and we can clean up the easy handles because we're done. That's how you do 2 transfers concurrently. And of course, as I said, it's not limited to 2 or 3 or 100. You can do any amount. And if that is not enough, libcurl has even more. So you can, as I try to emphasize, you can add and remove transfers at any point. And you can, in this case, I didn't show you because I wanted to have a more simpler example, but you can, of course, in this case, it's very easy to add, to make that curl multiple or whatever call you want to use yourself to wait for other file descriptors, because maybe you have your own sockets or pipes or things to wait for. You can put that into the event loop as well. And there's also this setup. You can set options to make libcurl, the multi-transfer, also change things. And even further, if you want to go up to do hundreds or maybe thousands of concurrent transfers, then I really recommend you to go into the multi-socket action function to drive the transfers. That's doing event-based sockets, and that's really how you can get performance transfers even with extreme amounts of concurrent transfers. it's been done. I remember years and years ago, someone did over 50,000 concurrent transfers using this API. And I would imagine that you can do much better these days, even if I haven't really tried to do this recently. You run into some interesting issues how to handle that many sockets in a local surrounding, but other than that, there's no limit really in libcurl. And if you want to get into, again, all that I've talked about today and a lot more details and more, maybe even better explanatories, I've written, or not only me, but we have created this book called Everything Curl on this URL at the bottom, everything.curl.dev, which really documents everything about curl in general, but also about the APIs and how to use the APIs and all the functions, all the callbacks, maybe not all the options yet, but in a more tutorial-like way. Not so it's a way to help you pretty much do or learn what I've told you about today, but in a book way. And of course, again, we sell curl supports. If you need help, we're here to help you. And everything this is open source, and we are always eager to get your help and contributions too. If you find problems, you want to add stuff, file issues, pull requests, or anything, patches, and you can help us improve and make the product better and the entire experience better, really. So thank you. That was sort of my intro on how to get started with libcurl. And if you have any questions, I'm quite sure I'm not as clear as I want to be. So I imagine that there could be one or two things that I didn't really explain well enough. So if you have questions, hit that little Q&A button or say something in the chat or just, lean back and think about how to write your libcurl code.
We don't have any questions at the moment. We can wait a couple seconds in case someone's typing something out. Also, I forgot to mention, if you prefer to ask your question and not type it out, you can click the raise hand button. I can unmute you to ask your question.
Yes, and of course, if you have questions after this presentation, like we're always available on email or whatever. You can ask me on Twitter so this is by no means the end of it. So you don't have to ask the questions right now. Yep, no questions. Then I think we're done. Oh, there's a question. Woohoo. Okay. Oh, building libcurl in Windows. That's a good question. And unfortunately, I'm not the best person to answer this because I'm not really a Windows guy myself. But my general experience with people who use and use libcurl on Windows is that there are so many different ways to get problems when you use someone else's builds on Windows due to memory setups and everything. So it seems that usually you end up happiest if you build libcurl yourself on Windows, because then you're under total control exactly how you built it under which conditions. And then in the libcurl project, if you get the source code, the easiest way is to either build libcurl with the command line there's a win build directory that you can get into, and there's a readme there describing how to build libcurl completely with just a make file, and it describes exactly how you can do it and how to enable and disable different options. And there's also pre-generated project files for Visual Studio that you can load and build. And I think those are the best ways to get libcurl for Windows. I mean, there are other ways. There are package managers and stuff like that. But I'm afraid I'm too inexperienced with those myself to be able to really recommend that. So if you want to use a package manager to get libcurl, then I would recommend that you ask on the curl library mailing list. about it, or maybe go to the GitHub discussions section and ask there, because there are a bunch of other quite a lot of other people that are better, more familiar with Windows for libcode development than I am. I'm more of a Linux guy myself. Well, thank you then everyone for attending. I will see you another time. There will be more webinars with more libcurl related topics, and also if you have any particular ideas or more details you would like us to talk about, or me to talk about, just let us know.
Yeah, okay, so since that's all the questions, thank you everyone for attending the webinar. Thank you, Daniel, for the presentation. And I hope everyone enjoys the rest of the week.
Thank you and bye.
Goodbye, everyone.